technical. We're going to talk about some experience over time and what's led me to start using Go. So, who am I? I currently work as a senior DevOps for Pulsera. They do acute, let's see if I get the marketing terms correct, acute care coordination. Mobile app talks to hospitals, that kind of stuff. Previously, I did some penance as a software development manager for Oracle. About 6 months, learned my lesson there. Before that, did some systems administration, more systems administration, and something for Zoot that's here in town as a criteria programmer at one point. In this previous slide, you'll notice the Swiss Army knife. So it seems like for whatever I seem to be doing, there's a term of the week or month or year. It used to be sysadmin, then I'd see the site reliability engineer for a while, and now I'm kind of stuck in DevOps. So whatever the problem is I usually get hooked into it in one way, shape, or form. So I don't know how many of you guys paid attention to the speakers list on the website, and it said something about a bear. So I wanted to take a couple seconds and address that. There's nothing more intimidating than Vladimir Putin on I assume it's a Russian brown bear in this case. And I don't know, I kind of thought it was funny, nice way to break the ice initially, and used to have this on my wall in a previous office. But if that wasn't, as scary as that is, it kind of reminds me back to something else of a previous era. I hope everybody's old enough to know what that is. Okay. Regardless, and maybe this is better. So I said I've been progressing towards Go, and there's a question then, well, what was wrong with the other languages that you've been dealing with? So I kind of want to go over those real quick. These are asterisks there, of course, because the term of the week deal. Common DevOps-y style languages, Python, potentially Ruby, Perl. Who knows, you might throw some Lua, some Tickle. The list has gone on over time. Then you have your other languages that are typically compiled, or maybe they're running into a VM, but these are often associated with building products and pieces. Versus the DevOps, these style things, you're not building a product, but you're either gluing or you're, most of the time you're gluing, let's be honest. So, what was I looking for? Over time, I started realizing there were some things that I wasn't happy with the tools that I currently had in my tool bag. And some of these are language nuances, lack of static types. I believe there was a presentation earlier about types. Deployability, speed of development, and performance. So first, let's go over language nuances. And first one that drove me absolutely nuts, especially in interpreted languages, or in the interpreted language front, was the lack of no actual main program driver, and the lack of flexibility of exactly where you're putting it. I'll show you an example in a minute. Also, issues with truth. Too much syntactic sugar, and poor scoping mechanisms. So for instance, we got a lovely piece of Python here. And you're looking through, the first thing I want to point out is, normally I don't do it exactly this way, but right there, what is that? And associated with that, I know the Python community, and let me back up 1 second. I used to be a flag carrying, waving member of the Perl community, and then I had an office mate that showed me Python and showed me how in about 3 or 4 weeks I couldn't read my code from the previous development cycle, so I switched to Python, and I've been doing a little bit of Ruby lately. So I'm not really picking on these because I've been a fan of all of them at one point or another, and I still use them. But in relation to this main program driver, the Python community will make an argument, well, you can take a file, you can put it anywhere, and you can turn around and import all the functions and classes, methods, and all those things as a library. Personally, if you're going to make a library, make it reusable. Don't just yank in random code from random sources. I also wanted to point out the scoping. I've met plenty of people and had arguments with them for a while on scoping. Python using an indentation-based scope. Granted, in a previous life, this really significantly helped out with code readability from a few folks I was working with. The indentation was awful. They couldn't figure out how to use an editor. Yeah. So there's the indentation factor. And then let's talk about truth for a minute, specifically on Python. This actually used to say this, but I was showing the gentleman my slide. Okay. So we have 0, an empty length string, an empty length tuple, an empty length list, and none. And none of those actually evaluate to true. After digging through, finding various issues and problems, and digging through other people's code as well as my own, it's become evident over time that this just isn't cutting the mustard anymore, and the amount of errors I'm getting out of it is ridiculous. So then we get to syntactic sugar. Anybody a big fan of list comprehension in Python? Ever have to turn around and unwind your code after you've done like 2 or 3 in a row and try to figure out what went on?
Variables, man, variables.
Yeah. So, Ruby, I'm just going to pick on it for just a quick second, given I've been playing with it lately. Ruby actually did, in my opinion, a lot better job on the truth statement that I was talking about versus Python previously. Although I really do not know how to feel about this end statement as far as scoping. To describe it, I'm starting to miss C-style curly braces, so that you can open up a random VI editor on any box out there, you could push % and you could bounce back and forth between scope without fancy plugins taking a half hour to set up your development environment. Because most of the time, that's never been a luxury that I've had until as of late of even setting up a development environment. Okay, let's talk about static types for a minute. Definitely started having an interest in static types for code readability. No more guessing games, and the thing that's missing on there is, some pre-runtime error checking, of course. Just a quick thing about. So there's and please don't judge me on my C. A piece of C sitting there, and you can see the static types. Oops. Okay. But where I was really getting at with readability with static types is the fact that I can actually look at a function and I can see what's going in there and potentially and actually what's coming out of it versus a randomly named variable in something like Python, and I don't know if it's a none or if it's 6 different various objects or what it is. Deployability. Deployability, specifically in my experience, I dealt with. You'll hear DLL hell, but then you also hear like dependency hell in general. Run into a lot of cases where there are underlying libraries that somebody else had relied on, and I wasn't allowed to change them or update them, which didn't work for my use case. And then trying to figure out exactly how to package them up, put them in different locations, make everything still stay and work, becomes tedious. And generally, depending on your, for instance, your production install process, sometimes those things take a significant amount of time. So, truth is deploying libs and managing dependency sucks. If I could, I would go preferably statically compiled. So, speed of development. So you hear me whining about Ruby and whining about Python and potentially other interpreted languages. So the right question would be, so all right, there's other ways to do this out there. Why not code C or C++? Well, especially in the DevOps realm, I typically don't have 3 months or better to write a product. It's 15 minutes or 2 hours, and maybe if I was awesome at C or C++, I could bust that out, or we'll even throw Rust in that mix. But the truth is, it's probably not going to happen. So I needed something that takes approximately about the same time if I were to do it in Python. And in addition to that, my peers have to be able to read my code. Does anybody code Rust in here or has played with it? Kind of homework. Oh, what's that?
I'm just laughing at you.
So then we have performance. Performance, I like something that would, C is fantastic, moving through. I don't need something exactly like C, but something also that's not just dog slow. Back to the Swiss Army knife thing. In a previous life, I had to turn around, or I was building batch submission systems. And, my language of the week was Python. So I started doing a Python and ran through threads. And we'll get to that in a minute. But I got some negative feedback on the amount of time it was taking. So I optimized and optimized and optimized. But the truth is, if I would use something else, I would have got the job done initially without spending the time doing the optimizations. So one of those things is, obviously I need, I guess it's on this slide, actual threading and the ability to use multiple cores. So anybody who loves their Python and multi-process, this slide's for you. So the question is, what now? So as we all do, we just jump onto Google and start digging around, and I'd actually done this multiple times. And finally, I actually ran into Go. Go is a language pushed by Google. It's garbage collected, and it's compiled. So Go, talk about some of these kids. We have Robert Pike. I'm going to talk about Robert Pike, Robert Grissmeyer, Brad Fitzpatrick, and on the bottom of the list here is Ken Thompson. Anybody know who Ken Thompson is?
C.
Nope, not C. Kind of C. Okay. Essentially the father of Unix. So he was actually, Ken Thompson was actually on this project and worked with a few of these other fellows for a term, and then pushed off and did something else. But let's talk about Robert here. He's done a bunch of work on Google's V8 JavaScript engine. Chubby, and to be honest, I'm not even going to try to explain that. Then you have GFS, which, as you know, is Google produced a white paper on GFS, and a lot of systems like Hadoop and other things have been written based on it. Then you have Sawzall, which is an internal Google product. It's a language specifically for smashing through their logs and performing analytics. Java Hotspot Virtual Machine, StrongTalk, and something amazing to do with Craig computers, I'm sure. So then you got Brad Fitzpatrick. Interesting fella. I actually, it's kind of sad to say, but personally insulted him at GopherCon in 2014. And I'd be happy to tell the story if anybody's interested later. But let's talk about what Brad done. Anybody use Memcached in here? Yay! So Brad was the original author of Memcached, or one of the original authors. He's done some other thing like Journal, OpenID. Yep. So what I'm getting at is these are pretty smart kids. Then you have Rob Pike, also known as the commander. And the funny thing is, if you look at his shirt, and you look at his glasses and himself in that particular position, if you put a couple of teeth there, it would almost be a spitting image of one another. So, Rob Pike, done a bunch of work so he specifically worked at Bell Labs. He actually worked with Ken Thompson and worked some with Dennis Ritchie. They were like 8 feet apart. He worked a lot on Plan 9 and Inferno operating systems, some various languages including Limbo that are associated with Plan 9, built a first Windows system for Unix, a couple series of text editors, and besides Sawzall, Newsweek, and other languages he's written, this one's always a good one. Co-founded UTF-8 with Ken Thompson. All right, so let's get to it. What does this thing look like? Now, as we've been talking about, I give you my list of things I was having issues before, and we'll just see how Go ends up on the list. So here is a hello world statement. So the first thing I wanted to bring up is, for once, I don't have to put, build a function and put it at the bottom of the file or anything. I can actually put the dang thing wherever I choose again. And because personally, whenever I open up a file in an editor, I don't like going to the bottom or trying to find the actual main driver of it. I want to see it as quickly as possible, especially if I'm trying to scan something in the middle of an issue. Notice the curly braces. Back to happiness with the % on Vim editor and running between. Wanted to bring up the package declaration. It's specifically for, I've done this, but I wouldn't advocate doing it ever again. You can actually take your main driver and split it with all your functions and stuff, and split it into multiple files for clarity. But then the question is why didn't you write a library or something else? But you can do that and compile them into a single executable. All right, so hey, you can see that it actually works. And here's where we're talking about static types. Oh, sorry, I made a mention of the curly braces, but I was talking it was in reference to scoping. But so here we have a read function, and although this piece of code needs to change because the slice is a reference type and it doesn't need a pointer, you can actually see exactly what this function returns right in the declaration of the function. No guessing, nothing. Oops, I left that. Okay, something on truth. Back to this initial list. Notice I tried to run this, and currently the you are having is 0. So 0 will not evaluate to true, nothing will evaluate to true except true, and or except true. Likewise, so of course I can set this to thing. So this is a member of the stringer. There's in the base library there's something called stringer, and for print statements or printfs or whatever you have, you can take any object type and implement this function and return a string, and you can then print it. Where's it going with it? Similar to like a 2_s or a Java 2 string or something along those lines. So deployment. Deployment's kind of interesting. If you have a 100% Go program, it statically compiles it, and you can take it and slam it around from machine to machine. You'll see that there's no dynamic libraries underneath. I've got 2 examples here. This first hello world, and the second one, this Slacker piece of Go here is a client that actually writes messages to Slack for me. But turns out I have some underlying C dependencies, and those get pulled in. Now on Linux, I couldn't figure out exactly how to do this on Mac OS X, and I found articles on it, but it didn't work out for me. But on Linux, depending on if you have the static library available, you can take those, program or compile them statically and ship them around. Another note on cross-compiling. So this specific command, using 2 environmental variables, as long as it's 100% pure Go, you can cross-compile on Mac OS X and ship it to Linux, and it'll just work. Likewise, you can do that. A gentleman that was supposed to be here that works at Data Miner by the name of Ryan Chapman was supposed to help me give this presentation, but flagged out because his buddy had a wedding. But he actually ran into this particular use case last week where he cross-compiled from OS X, and then ran it on Windows. So, if anybody's seen anything about Go, the first thing that always comes up is Go routines and potentially channels related to performance. I'm not going to get into channels too much. There are hell of a lot smarter people out there to talk about them and not lead you astray than me. I've used them, but probably be best to take their advice. But I would like to talk about Go routines for a minute. So here's a simple thing that actually my DevOps stack for Pulsera here makes GET requests out to it. The actual how to implement the concurrency itself is remarkably easy. That's all you have to do. And that's usually the presentation you get from people who are like, if you want to make something concurrent, make it go faster, all you gotta do is put Go in front of it. The truth is that's a little bit of a lie, because the right answer would be, so why do you have the sync package here and wait groups? The answer for that is it is concurrent. The problem is if I don't wait for the main thread or wait for the other threads to close out, the main thread will close and the operating system will destroy the process, not allowing the rest of them to finish. So, yay! So that's what it takes to make a concurrent program. Channels are really interesting. Hopefully I don't mess this up. I think it's Thomas Hoare. Communicating sequential CSP, yeah. A bunch of the way Go is written in relation to channels has a lot to do with that paper. But like I said, I would defer to you to, if you have an interest in the language, to look up a couple of Rob Pike's or other folks' presentations on channels. Okay, so regardless of concurrency, it's kind of a lame real-world example, but it's the truth. Previously to Pulsera, whenever I was at Oracle, we had an issue. We were a systems administration, DevOps, whatever you want to call it, department underneath another one. Well, the department above us controlled all the RPMs and the Yum repos, and we had to sync them across networks. So the idea was to keep the data down to as minimal. I can't remember exactly why you couldn't simply run an rsync, but it did not work out. rsync ended up syncing all the repos across. So the use case is you had to process all these RPMs and figure out what exactly changed, specifically the XML data associated with them. So the gentleman, Brian Chapman, I told you that isn't here because of wedding, he actually come up with this graph. And what this is a perception of the speed that it takes to actually, it was like 3,700 records or something like that is what he said, which seems like, I'm not sure why he took that, but it did. And the development time associated with that. So you can see Ruby and Python, and the premise of this is without having a knowledge of the language, when you don't know something, the first thing you do is you go to the Google Webs and you turn around and you try to find something. So this is based on like a series of Stack Overflow articles and how these implementations come about. So to do Python or Ruby, it took roughly 30 minutes in order to implement the solution. Go took, looks like a lot higher, but 15 more minutes to implement the solution. The trick is Python took 8 seconds, Ruby took 65 seconds to run, and Go took 2. This is without concurrency, just bare bones. So it doesn't matter what kind of language or anything else you have unless you have fantastic tooling. So let's talk about tooling for a minute. First one is, how many people have had this argument? Oh yeah. So, who was on Team Spaces? So it turns out in this what was that?
I was looking at everybody else. It was funny.
Okay. Oh, nice. So that's what I felt about it before as well. So related to tab versus spaces, the first fun tool that comes up with Go is GoFont. takes all your files, we'll rebuild them into the community agreed on spec. The trick with this is there's no arguing or anything else. If you need anybody to take your code seriously, if you don't run a GoFunked on it, you're out. Fortunately, it's really nice to run, and you can embed this in the Vim so that every time you save a file, it runs GoFunked, completely reformats your code, and everybody's happy. GoGet, if you're used to something like Bundler, or which it's kind of a swear word in some aspects, but GoGet is a tool to go get dependencies off of GitHub, Bitbucket, Mercurial, and other things to put into your project. GoVet, static code analysis, looks around, tries to make determinations whether or not you did anything stupid. It works okay. It has a lot of, from what I've read and what little I've even used it for, it has a lot of false positives. The next two are the interesting ones, and I really should have put one about a picture, and I can here in a minute, but this one is quite interesting. So you build something, and you run race. So as we were talking about all those Go routines and concurrency, built into the tooling itself, you can run the race detector, and it will look for deadlocks as well as races on particular variables, and will detect them for you so you can fix them before it goes out to production or anything else. Really easy to do. The pprof is quite unique. If you need to do some performance analysis, you can build a file out, run it on a website, well, a localized website, get some beautiful visuals as well as graphs on, not just graphs, but statistics on which pieces and parts of your code are hotspots, and if you need to perform optimizations. So, somewhere in the ballpark, I guess. So I'd pretty much be a bigot if I didn't stand up here and talk about some potential issues with Go. So one of the things that I told you about the stringer interface, and it provides flexibility, but versus like something like Java that suggests that you implement an interface and it's actually part of the code itself, Go doesn't have that. That part doesn't bother me, but especially if you are new and you run into Go, you'll run into things where you're like, I don't have any idea what this interface is. And it would be really fantastic if there was a tool to rip through all the libraries and everything else and look at your code and tell you which interface that this is, or which interfaces you could potentially implement it. The next one is a religious war, lack of generics. A lot of the Java folks get upset about the lack of generics. The Go people say that you don't understand Go. I'm not really going to get into it. The arguments are hilarious, and some of them just kind of sad. So I'm not going to give you a pitch either way on that one. Over implementation of channels, I was talking about synchronization mechanisms, and a lot of people say they can be slow. The funny thing in my experience is some of the people who were implementing those were building their stuff into Python to begin with. So I don't understand why they have a language that outperforms or significantly outperforms it, and then they're whining about one little thing being slow. It hasn't caused me any issues, but I can understand if you were trying to significantly, build an awesome machine. There's a question that maybe you should have built it in C++ or C to begin with. There's a possibility. And the last one is a very common one. Errors can be monotonous. I didn't show you errors before. I got a little slide here for a minute. I view this, it's very annoying, but I also view it as a feature if you've had to debug a lot of other people's code. So you can see here that we open a file, we hit error. Don't worry about the defer statement for the minute. Then we check for error, and then we pass the error up. So there's no concept of try-catch block or any of that fun stuff or exceptions. All errors are a type, and the typical standard for it is if you care about errors in the code that you build, the last argument will be an error type. So handling errors can be extremely monotonous as part of coding. Although the nice thing is it's extremely explicit. You can actually trace the code piece by piece by piece through. if you've ever had the fun-loving experience of finding random exceptions all over the place, and then somebody catching an exception one way, which masked it from a different thing because they had caught it and masked over top of it. This actually works out pretty nice, although kind of verbose. So what was all of this about? Obviously, it was my sales pitch on Go. I really like the language, but it's definitely not perfect. Tied back to DevOps, especially from a monitoring context, every particular process that you have on a machine has a cost associated with it, especially when you get to dealing in cloud machines and things versus previous experience at Oracle. We had these big monster machines, with half a terabyte of memory in them. And that's fantastic if you have those resources. Been working for a startup right now, and my own personal projects, I kind of like being able to run multiple services as well as MySQL database on a $5 a month box. Speed of development is extremely important. Like I said before, after you get used to the language, it's not far off. In some cases, it's way easier to deal with than Python in some. And the last thing is finding, nice taking a picture of me. Finding code issues during compilation versus runtime is awesome versus that dreaded stack trace from something blowing apart. Wanted to say thank you, and I was a little nervous. I usually have technical talks with a beer in my hand outside of work, so this is a little different. But hopefully everybody has had a good day today. Enjoy your evening. Any questions?
How did you make your slides with the live editing and running of Go?
That is a Go program. This is a tool called Present. Let's see if I'm smart enough to do this right now. I don't remember can you see it or not? Those are my slides.
It's like a markdown file?
Yep, markdown file, little things with image, and down there farther is code highlighting, and you put some markdown markup and comments in your other source files, and you can pull them in via code, or you can run play, which will actually execute them and put them in. It's a pretty neat feature. It has some GitHub integrations, but I didn't go with it.
What is the name of it again?
Present.
Present.
Yep.
So do you miss having a REPL, the interpreter that you can try out new parts of the language, test out a couple of things, or what's your workflow when you don't have that?
Yeah, of course I miss it a little bit. But the one thing I didn't bring up, I obviously missed that, but there are some other ways to get around it if you're just dinking for the minute. Love AWS.
What you're saying there almost could you use like that presenter as that?
Yep. And actually, so if you...
I mean, the difference though is that you have the variables in memory, so you can keep testing it over and over, whereas with presenter like this, you have to change the code and run it all again.
Yeah.
Change the code, run it all again.
The fortunate thing is that it compiles extremely quickly, and if you're coming from Perl, I didn't have that before. So then I got to Python, I'm like, this is great to be able to have this interpreter and monkey with it for a little bit until you really get far along the process, and you're like, so how do I get this out of here? And then you got to pull in read line and do all that stuff and build the file. So it doesn't really bother me in the end. And the thing is it would hurt a little more if it was a two-step compilation process, but you can actually do go run and not just go build and build the executable. So it just runs it as if you were executing a script. But yeah, I still miss that. Yeah.
How has your experience been with managing dependencies in your Go programs?
I've seen a lot of complaining about that. For me, it hasn't been a problem. Based on my previous background, usually I go grab something, I look at it to make sure it's not toxic, I check it into my repository, in the end, and I compile against it from then on. There are projects like Dave Cheney has an interesting one called it's GB, and it intends to help out with a lot of those things. But there's still some work to do with that specifically. But to be honest, it's never really bothered me. And maybe it's my experience versus somebody else's.
Have you found a better means of debugging other than like print statements for Go?
Maybe see Delve.
No.
Delve is one. There's like 3 different projects at this point that are underway. I think at this current time, I think Delve is the main one. You can use GDB. Yeah, good luck. I've seen how you can do it, and it's fine. But so far, the best I've seen at this point is Delve. But the community is working on it.
You mentioned GDP loads. You mentioned GDP as an alternative. What is that?
GDB debug.
GDB, the GNU debugger.
Okay.
But to be honest, I haven't pushed into that. I'll go to Delve or some other project first before dealing with GDB.
So you had a chart up there that showed the relative build and execution, or creation and execution times.
Yeah.
It looked like a Go lost.
Did it?
Well, if you only ran it once, how many times did it?
Right, that's what I was thinking
That's
too.
right.
It takes 47 minutes total with Go, and compared to Python, that's slower once.
Those are seconds for Python and for the red.
Well, the blue is the development time.
Right. Okay.
Minutes.
The execution time is the 8 seconds or the 8 minutes versus 2 minutes.
Those are seconds.
Seconds. Even if they're seconds, it's 30 minutes, 8 seconds, 30 minutes, 45 minutes, 2 seconds.
So
Slower the first time. Yeah.
So the rest of the story is the project with this graph. The project started out and it was a lot bigger sample set than this. The initial thing was Ryan, who had written this, wrote it in Ruby. So it would take 4 to 6 hours to potentially not completing it all. He switched it to Go in the end, and it took 15 minutes. He didn't try Python because he was too hung up on the idea that the indentation scoping was so awful. And at this point, I kind of agree.
Have you tracked at all the latest in Python 3 with optional static types and async?
I have not. I do have another slide on here that shows, are you familiar with PyPy? The PyPy comes in right with Go with 2 seconds on this particular XML execution. But obviously, as any good politician, I'm skewing my results in order to make my point, right?
It seems like there should have been a bash where the implementation time was 15 seconds and the runtime was 2 minutes.
Probably. But anybody else? All right. Well, everybody have a good day. I'm glad you showed up at Big Sky DevCon.